do you want me to go over first? What?
Start with number 5.
Are we serious?
Yes.
Okay. So here, let's start with number 1. Open your eyes. Oh, there it was. So number 1 is asking me to find the focus and the directrix of the parabola whose equation is y equals 1/4 x squared. Now, the formula that I gave you isn't in that form, is it? It actually reads x squared equals 4yp. So the formula that I gave you is x squared equals 4yp. So I need to try to make that look something like this. So if I have the formula y equals 1/4 x squared, I want x squared by itself. The opposite of multiplying by a quarter would be to divide by a quarter, or I can just use the multiplicative inverse, couldn't I? So the multiplicative inverse provides for me 4y equals x squared, and then I can use my reflexive property to just flip that. That means that x squared equals 4y. So the magic question here is, what is p? 1. So my parabola is centered at 0, 0. The focus is positive 1 unit up. So my focus will be at 0, 1. And my directrix is equidistant. Therefore, it's going to be at y equals -1. And we're done.
So wait, x squared equals 4yp.
Yeah, Karina? It is 0, 0.
Yeah, but
Has y been changed? Have I moved? Have I translated y?
No.
Have I translated x?
No.
So then where else would it be, right? Thank you for that question. Fantastic. Sir. Behind you. Wait your turn. Go ahead.
How did you find the directrix? You said
Well, P is the distance from my vertex to my focus. So that means that it's got to be 1 unit above it, correct? And remember what I said about a parabola? A parabola is simply a collection of locus or points that are equidistant from the focus. So if this is 1 unit above, then my directrix needs to be exactly 1 unit below.
Wait, so so is x squared equals 4yp the formula or something?
Actually, it's 4py, but I wrote it. It doesn't matter. It's commutative, right?
So
The formula you actually want to be using is 4py.
So is that the formula?
Yeah, that's the formula for the parabola.
Oh.
Where p is simply the distance from the vertex to the focus. And that's it. Yeah. And that's the proof we're going to do today. I'm going to prove to you why it's. Remember I said take my word for this? This is the formula, and then I'll show you what the proof means. Because this isn't supposed to be hard. It really isn't that tough. Go ahead.
wait, how do you know that? How do you get like 1 as P?
Well, 4p, do you see? Because see, here's x squared, right? And there's the y. How does 4p become 4? Only if p is 1. Math!
Okay.
Go
Yeah,
ahead.
I need to redo it.
there's one like the 4y equals 1.
Okay, your volume just went like exponentially lower every single time you spoke a word. So by the end, I just heard it wrong.
Could you explain the 4y equals 1/4 x squared?
So you want me to do the problem again?
Well, not that, just that part.
That's the problem.
Like I get everything else. But just,
That is the question. So I'll do it again. I have no problem with it as long as it's a legit question. So let me erase all of this.
Take it slowly, step by step.
I did top putty tat.
I know, but take it slowly, like take it easily and slow. No, like that.
Faster than that.
Okay,
Wait,
sorry.
I need time to process, that's why.
Okay, I see what you're saying.
So explain it simply. Does that make sense?
Okay. Let's do the proof, and hopefully the proof. Actually, no, because
Wait, I just have like a simple question.
that's not really. It's that's the whole lesson.
But what
Let's talk about this again, then. Let me do this. Okay? Let's create a line, aka directrix. Cool?
Yeah.
Starting over again
So
here.
directrix is a line.
It's just a line.
Okay.
It's an important line because I'm going to create a directrix and I'm going to create a focus. Though this is going to be what I call the focus. This is the directrix. That looks like a P.
So is the focus the distance from the vertex?
Just wait.
Okay, I'm sorry.
If you're asking me to start over, you need to not be filling in any blanks.
I'm sorry. I'm just trying to figure everything
Okay?
out. Just ask for the definition.
Focus directrix. Everyone's good?
Yeah.
I want to find a collection of points that are all equidistant. Stop. Thank you. I have a focus and I have a directrix. Now the reason why the directrix is a line is because I'm going to find a collection of points, lots of them, that are actually going to go on to infinity in left and right. Therefore this line expresses that, doesn't it? That it goes on forever. Now, the focus is simply 1 point, so I don't have to have a lot of those. It's 1 point. What I want to find is a collection of points that are all equidistant from focus to directrix. They're all equidistant. So, and those points we call locus, except for one important one, which is the lowest point, or it could be the highest point, aka vertex. Now, if I just drew a simple perpendicular line here, somewhere in the middle, a midpoint is a point that is equidistant from focus to directrix, isn't it? Okay? That's my vertex. I can find a second point, probably somewhere here, that will also be the same distance this direction as it would be in this direction. Right? I can't just go straight across, because if I went straight across, then obviously we know that's a triangle, therefore this distance would be longer than that distance, so that doesn't work. A parabola is simply the collection of all those points. So that's why our parabola kind of looks like this. So any point that I pick on there has to be equidistant from the focus to the directrix. Okay? Understand the purpose of focus and directrix now? Okay? A lot of you have already seen a focus at play, at work. Okay, raise your hand if you have seen a satellite dish. I think everybody has, right? Satellite dish kind of looks like a parabola, and it's got like these antennas and a little some right here in the corner. At the tip, that's the focus of that parabola. Whether it's a TV dish, or if it's a sound, or if it's sending your cellular waves. What that's doing is that it's collecting all of the different waves that are out there, and it's going to bounce them back, guess where? To the focus. So that you can receive a signal or a TV image or whatever it is. So that dish kind of collects everything in that spot. Now, anyways, that was just a little side note. To find the equation of this parabola, which we will prove after I answer some questions, is x squared equals 4py. X and y are simply variables. We know that. We plug in an x, it spits out a y. Same thing, plug in a y, spits out an x, correct? The only thing that's not known here is this variable p. I'm telling you that p is simply the distance from the vertex to its focus. If I have to move up, then p is, I can tell you the position of the focus and directrix. Why? They have to be equidistant from the vertex. Capiche? So, when I go back to this problem, I have my model here. It's x squared equals 4py. This equation doesn't fit my model. It's given to me in the quadratic form, I guess you could say, the standard form. Okay? I need to change it so that it looks like my focus directrix form. So what I'm going to do is I'm going to try to make this equal x squared, just like it is over here. But I have to get rid of the quarter. To get rid of the quarter, I'm going to multiply both sides by 4. So a quarter of 4 is simply 1. Therefore, I get 4y equals x squared. Using my reflexive property, I can write that as x squared equals 4y. And here's where the comparison begins. We know that this and this are simply variables. They change. Okay, because they can represent any one of these points on the parabola. But I want to know is where that distance of the focus is, because that's going to determine a lot of it, isn't it? So, well, this variable here tells me exactly that. So my question is, how does 4p become simply 4? When p is 1. Therefore, the distance from my vertex to my focus is 1. So this would be 0, 1. My vertex is at 0, 0. So if my focus and my directrix are equidistant from the vertex, then where is my directrix? It's at -1. Down here 1 unit, right? But it's a line. So I have to give it an equation, y equals -1. And there it is again. Dusty. I did say dusty.
No, it just reminds me of growing up in elementary school that
Ew, Dusty Burns.
Hey, none of that.
What?
I was just referring to the Daniel video where he's like
Dusty.
dusty.
It's Dusty.
Oh no, there's this brand Dusty Barnes.
What?
Dusty, not Dusty.
Dusty?
Stussy.
What's Dusty?
It's a brand. Stussy, whatever you want to call it.
Vans are not Dusty.
No, the shirt he was wearing. It's Dusty.
It's Dusty, not Dusty.
Stussy, Stillsy, Stassi, whatever you want to call it.
I guess that just goes to show I've never bought one of those shirts.
She gave me a hug.
Questions on number 1.
It's okay.
No,
I have no clue what it was.
Wait, shh.
Did we
Kara has a
just-
question.
Kara. Silence. Thank you. Go.
So going back to like when you're explaining like the parabola or whatever, and you said like the highest like and lowest point is the vertex.
Correct.
So would the locus be the vertex or no?
A vertex is a locus, but it has a special name. Just like,
The square rectangle thing. Like a square is a rectangle, but not all rectangles are squares.
nice. That was a good example.
So like the vertex is a locus, but not all locus
Are the vertex.
Because the parabola is still a locus, right?
Yeah, it's one of the locus.
Okay, yeah.
Give me this, it's great.
Alright.
Every time you ask a question, Jared answers it, and then someone's over there saying the same thing that he just said. He's like, it's funny.
For Jared, speak up.
Yeah, you can be louder than that.
No, but you can probably hold him.
Yeah.
You know how when a parabola is positive and when it's down, y is negative? When
P
it's,
is negative.
Yeah. When it's side to side, what is it?
Okay, we'll talk about that. Not right now. Well, actually, if you want to. Thank you. So, Caleb just asked me, hey, you know what? This is an upward-facing parabola, and if P is negative, then it's a downward-facing parabola. How do you know it's a horizontal parabola? And it's a horizontal parabola. It's a totally different equation. Well, not totally different, but it should make sense. It's a y squared equals 4px. And if p is negative, then it would flip and face the left.
So just the y and x flipped when it's horizontal. Do you have cough drops? No? I mean, I kind of need one. See, Kara's helpful.
All right, cool.
The computer's performance is slow.
Another one.
Okay, so write the equation of a parabola with a focus of 0, -2. Okay, so 0, -2. This is my focus, and my directrix is y equals 2. Okay, do you see it? There's y equals 2. So where does my focus sorry, my vertex have to be
0,
0, 0, because it's equidistant. So there it is. Okay, so now I know, just by looking at this, my directrix is above, my focus is below. You see what I was talking about here? So now I know that this is going to be a negative parabola.
Okay. Yeah, I got it.
Yes.
Is it probably stupid, but will the vertex always be 0, 0?
No. No. If you've translated the parabola, then it won't be at 0, 0. Okay?
Wait, we'll tell you if the vertex
So,
is going to be at 0.
here's what I know. Say that one more time.
It is going to tell you if the vertex is going to be at 0.
Eventually you'll be able to figure it out. So, here's what I know. It's a vertical parabola. So it has to follow the form of x squared equals 4py. And all I really need to finish this equation is to plug in p. Well, what was p?
2.
Not 2.
Wait, 0. No, wait.
Negative 2.
Negative. Okay.
I had to move down 2 units, didn't I? So that means that x squared equals 8 times negative 2y. Therefore, the equation to that parabola, sorry, I did the math already.
Yeah.
Thanks.
I did the math already. So it's negative 8y, and I'm done. There it is.
Sweet. Oh, right. All right. Ask him yourself, Kara.
So, Mr. Munoz, can we get a redo on our homework? Because I did this completely wrong.
Yeah. I think till Monday.
I did it completely wrong.
Yeah.
I'll pay you.
Yeah. No, it's fine.
I'm gonna redo it anyway.
Now, since we have this up here, I want to go and show you what a translation looks like. Okay? Let's take that same parabola, but now it's not centered at 0, 0. I want to center it at, let's go 3. So I want the parabola to be here. Okay, so it's same parabola except I've translated it. Everyone with me? So I'm going to do it in blue since I haven't used that number.
Isn't that number 3?
The color blue.
Yeah, you said you hadn't used that number.
Yeah.
Blue is my favorite number.
It's my favorite number too. Actually, I like orange.
That's a first.
What?
I thought your favorite color was green.
Orange, red.
Neon orange. What do you think?
Okay.
Your shirt's green.
Minty.
That's turquoise. It's green.
Go ahead.
Because it's so
It's green with the...
How did I get from my vertex to my focus? That's all that is. I think I said that. Okay.
Mr. Munoz, I have a quick question. What color's her shirt?
Turquoise.
Mint.
Thank you.
That's like This
We
is like Mr.
decided-
G's
we
class all
decided
over
it's
again.
aqua.
It's light aqua.
I say minty.
She's calling it
It's minty.
swatches.
Hang on. Here we go.
Edith, this is like
This
Mr. G's
color?
class all over again. Is it
Solid?
pink or
That's
is
not
it
that color.
salmon?
That's darker.
Okay, this is the closest I can get.
Yeah, so it's not that
But
color.
it's minty. It's a minty
So
green.
it's not that color.
All right. Anyways,
Edith, this is like Mr. G's class all over again. This is pink. Something like Jenna.
you ready, Jared? So here's my parabola. This red parabola I've translated to this coordinate, which is what's the coordinate here? Negative 2, 3.
3.
All right, you guys ready?
Yeah.
So it'd be
X plus 2 squared equals negative 8, y minus 3. That should make sense to you because you have done something very similar.
So did you do number 3?
No, this is still number 2.
But
But this is a different
Same.
equation.
Oh, that's just a happy coincidence.
He's just
He was
translating.
showing us how to translate
oh,
it
because
and how
number
we grade it if it was
number 3
translated.
had a vertex of negative 2, 3, and that whole equation thing. And okay, continue.
This is still number 2. All I did was show you how you would translate a parabola. The red one is still x squared equals negative 8y. However, the green one would be the equation in blue. So,
So for the translation, do you leave it like in that equation or is there more?
that's the equation right there.
That's it?
That's it.
I feel like there's more.
That's right there, bro.
I can't breathe.
So if you were to, let's say if you were given that equation, you're told to solve the parabola, would you take out the +2 and the -3 to figure out what P is?
No, because you need to know that, because what they'll do is they'll give you an equation. They'll be like, all right, where is the focus and directrix?
Yeah.
So if it's been moved, am I going to be able to find the right positions if I assume it's 0, 0? No, I have to first find that and say, oh, my focus would be 1 unit under that, or depending on whatever it is. In this case, 2 units under that, and directrix would be 2 units above that. And there's an example like it in the homework. We'll probably get to it in a minute. Go ahead.
Why did you go +2 -3 if the coordinates are -2 positive?
Okay.
Isn't it like the thing?
It's exactly like we did with the circles,
Yeah.
but that's okay.
Yeah, but you would have to flip it.
We know that in this case, x equals 2, -2, x equals -2, and y equals 3, correct? So let me get rid of this here, because I want you to know that the vertex is at those, right? So x equals -2, and y equals 3. How do you feel about that equation? That's a lot of equal signs, huh? I don't really know what you're talking about. So I can use some algebraic manipulation and say, all right, well, if x equals -2, I can add 2 to both sides, right? +2, that's a horrible plus. But that's x plus 2 equals 0. Now, by adding 0, have I changed anything? No, but I can definitely plug this in so that I can express to you how x has been modified. And the same idea would go with my 3, where it becomes y equals, not y equals, y minus 3. So now I know, oh, it's what makes the 0. So think about this as this telling you how to get your vertex back to the origin. See it? That's why they're opposites. And that's important to know. It's what makes that 0. Because later on, you actually have coefficients in front of the y's, which pretty much just produces a fraction value. But you need to understand that it's what makes the binomial here. Sorry, not the binomial. Yeah, the binomial 0. Okay? Thank you. Anybody else? Do another one?
Yeah. Another one.
Stop. Can you do number 5?
Yeah, can you do number 5, please?
Wait.
I'm not sure how to solve equations like that.
Yeah.
I'm just trying to go in order here. I need number 3.
You're just trying to get me to do your homework.
No, I did it wrong. That's why I need to do it correctly. Do you see my homework? Okay.
I don't actually see it. That's more giving you a hard time right now.
Using the computer lab if you work for
I love the way you ask me a question and don't let me answer it. But that's okay. So here they gave me an equation. Now, just by looking at this is going to be a horizontal parabola. And I know this is a horizontal parabola because y is squared. Do you see it?
Yeah.
So, I need to rearrange it so that it follows the y squared equals 4px form. And that's done by going y plus 5 squared equals x minus 2. Correct?
Yeah.
Someone just double check my work.
Wait, why are you using y squared?
Because that's what it says.
Why would 2 be over by x?
Well, I moved it. I went minus 2, minus 2.
Oh, wait, never mind. I see.
That's what I'm saying. Check my work.
I need medicine.
Check my juke. Check my juke.
Check my health. I need medicine.
Oh, never mind.
Mr.
Okay.
Joe's.
I forgot we flipped
I
it.
know you're not a nurse, but do you have medicine?
I don't. I have math.
Math is a
Math gives me a...
Math is life. So if I give you more math, you'll survive.
Math ruins my life stuff.
I don't think that's
What?
how
It's
it
not.
works.
It's not.
Do you know how many breakdowns I've had this year because of geometry? I think most of us can relate here.
No, all of us have just heard your breakdowns.
Have you been in my house? No.
Okay. I did not force any one of you into this course. Everybody did it willingly, yes? And at semester, you had a chance to like be peace, but you chose to stay.
But you would have had to take in this class anyway.
Yeah, that's
so.
what I'm doing.
You don't have to take honors.
Not
though.
honors version. So
What's the difference between honors and regular?
Honors is cheaper.
it's the breakdowns that you're having.
It gives you more of a chance.
The last Galileo that we took, they took that Galileo today.
So they have longer to do things. Okay.
And they don't have to do a lot of the plus standards. So a lot of the proofs that we have to do that you need to understand, they don't have to. Like the proof we're doing today. They won't have to worry about it. All right, anyways. Shh, silence. Here we go. Now, is everyone okay with this equation that I have at the end?
Yeah.
Now, I'm going to do something extra to this. I'm going to put this like this. I can. It's a quantity, isn't it?
Yes.
It's just a quantity. But then I can clearly see that there should have been a p in front, huh? So how does 4p simply become 1? If p was how much? 1/4. Good. So now,
Wait, wouldn't negative 2 be p?
what? No, because it's times something.
Oh, okay.
It's not minus something. Go ahead.
I'm still lost on how you got 1/4.
Okay. If by doing this, all that 5 and this have become are translation values. So if I ignore those, kind of like you were saying, if I ignore those, I've got y squared equals x. So how does y squared equals 4px become simply 1? Because if it's a quarter, correct? Okay, so now that we've gotten that taken care of, let's think about this. I need to identify the equation of the directrix, which I can also find the focus very easily. But here's what I need to do. Where is my vertex? Well, my vertex is at -5, comma 2. That is my vertex. Okay? This is a upward facing parabola, right? And I know that because this 1 is a positive. So it's going to look like this. But now, because p is a quarter,
Wait, isn't it y? So isn't it sideways? Or wait.
oh, my bad. You guys are right, I'm wrong. Thank you. Good looking out. So it's going to be a sideways parabola. Okay?
Wait, okay.
Thank you. And it's positive, so it's got to face the positive numbers. So now I know that my directrix is simply a quarter unit behind it, correct? So that means I'm going to go this direction, another 1/4. So if this is at -1, 2, 3, 4, 5, then the equation should be x equals -5 1/4.
I just got them.
Wait, what? Can you go back one more time? This thing.
What are the coordinates to this vertex?
-5.
It's -5, comma
2.
2. According to my p-value, I shouldn't say that, to the value of p, my directrix is only a quarter unit away, isn't it? Okay? So if I go a quarter unit this direction, isn't that -5 minus another quarter?
Okay.
So there's the equation of my directrix. And if I wanted to find the focus would be at
-4 3/4.
exactly -4 3/4, comma 2. There you go.
So it's a 1/4 is the distance, right?
It's simply the distance
Yeah.
from vertex to focus. Okay? Chakalaka, chakalaka, laka, chakalaka, boop. Flippity floppity flip. It would be what number is in front of here. Okay. There's no number in front of it, it's a 1. So it'd be just regular 2, I guess. Now I think I do need to make a correction though. let's talk about this real quick. If I do have a directrix and a focus, that creates some parabola, correct? Where all points are equidistant. If I were to take this focus and move it upward, then what's going to happen to my parabola?
It'll come in.
It's going to close up. Am I saying that correctly? And I saved I think I did.
Easy part.
Where's my favorites?
Go to Desmos.
Click the star thing.
No, that makes it a favorite.
No, the list thing right next to star. Show all bookmarks.
So it's not that. Maybe it's in Chrome. Hi, Chromie. How do I do this one?
I don't know, I don't use Chrome.
What?
Your favorites are all right there, aren't they?
No, that's not all of them.
Those are bookmarks.
Other bookmarks, right there.
Where?
Over.
Where it
There
says
you go.
other bookmarks? Oh man, I got so many. Let me just do it again.
Go to Desmos.
Focus, directrix,
The one below it?
applets. Here we go.
GeoGebra.
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 It's algebra and geometry together. Alright, so check it out. Here's a parabola, it's a sideways parabola, but here's a directrix, here's a focus, and as I take the focus and I move it away, oh, it gets wider. Here we go. So as I move it up, it's going to get wider. If I move it closer, it's going to get skinnier. Okay? So, because remember, all the points have to be equidistant, don't they? And that's why. So, if I were to here, let me see if I did this yesterday with some peeps. So let's do, like right there. No.
Could a focus and a vertex ever be the same point and then have the directrix?
Then it would be a line.
Okay.
So let's see. Let me put it right here. I wanted to get,
So a line isn't parabola.
let's see, here we go. Close enough, huh? So here's what I did yesterday. Remember I said all points on all the locus have to be equidistant to the directrix? So if I measure, I'm just using that point because it's closest. That's about 15 inches, which means that it should be 15 inches from, well, did I say that right? Yeah. Oh, focus, 15.
You're basing.
No, you're basing it off of.
Oh, what am I? Oh, there's a directrix.
Yeah.
Ah ha ha, JK. I'm like, why isn't that working? That is about 11 and a little bit more. And then this should be 11 and a little bit more. See it?
Yeah.
Yay. Okay. Now, we're actually going to do that proof, though. So can I stop with the homework?
I guess.
Sure.
I'll be coming in for tutoring later.
Probably come in like Monday.
It's not like I needed help or anything. It's okay.
And that's what tutoring's for.
What was that? Is that a no? Here. Say something, I'm giving up on you. Okay, clear page.
Is there tutoring Fridays?
Where's my... No tutoring Fridays. Okay. Alright, cool. Let's start with so this is proof right here. This is our proof for the formula of the parabola. And if you need me to slow down at any point, please let me know, okay? Because when I start mathing, I just keep getting faster and faster and faster. I think we've noticed.
Yes.
My bad. What? No, I can't do it like you can, though. Do your Minnie Mouse laugh. That's pretty good. Okay.
Wait, slow down. I still need to get my paper out.
So you need to hurry. I ain't got all day. I only got to 2:55. And we're in for the long haul, baby.
Jack's
Yeah.
picking me up today. He wanted to come say hi.
Very cool. Make sure he gets here before 3:10 because I got to get to tutoring.
No, I'm asking. He has a torn ACL, so he can't walk very well right now.
Aw, sad face. Where's he gonna pick you up at?
Parking lot.
Front parking lot or back
Front.
parking lot?
Oh, I'll try to get over there. Say hey, baby.
Okay, I'm ready.
Is everybody ready? Are you ready for this?
No.
Not really.
Wait, I need to
Okay.
draw my lines. Wait.
I don't think he is.
Yes, I am recording.
Can you please record?
Do it.
Yes.
I can play videos. I don't think you understand how body language works.
Huh?
I don't think you understand how body language works.
No, I don't.
What? Why won't you?
Stop. That's frustrating.
Oh, please,
He
can you
was
repeat?
thinking about it. He was like,
I did. I have to pause for a bit to like get into process.
But please, can you
Well, that's
record?
because you're doing the opposite of what you say.
Yeah, but that's good for your brain.
It is?
Still, can you please
Yeah, here,
record?
try this.
Yes, it is.
Make one hand go up and down, while the other one goes forward and back.
Wait, hold on.
It like goes up and angle.
Not wax on, wax off. One hand up and down,
What happened?
and then the other one forward and back.
This like starts going at an angle. It's weird.
Okay, I'm doing it.
I got
so
this.
formulas.
I got this. Hey, somebody else.
Yeah, here we go.
You're a DJ.
Someone give me coordinates for this point.
Get it started.
0, 0.
Thank you.
5-4.
It's 0.
I'm doing it.
It is 0, 0. That is a fact.
Oh, I thought you were asking for a coordinate, not what the coordinate was.
No, that's a fact. Okay? Now,
This is-
I'm going to place another point above that, which we'll call the focus, but its coordinates will be 0, P. Right? Because remember I told you P was the distance from vertex to focus? Right? That means that below that, I should have my directrix, which will be at y equals -3.
Wait, I'm still writing.
To the
No, what the heck am I talking about? Not -3. Negative P. Remember, it's a distance. Sorry, it's -3. It's because I counted. I shouldn't have counted.
Please
That's
be
bad.
careful. I'm writing in pen.
It should be at y equals -P. Because remember, the distance that I go up has to be the same distance I go down, correct? And because this is a proof, this proof should work for all values of x and y,
What?
not just some.
No
Okay.
shit.
So are we good? Make that correction, please. All right, cool. Here's what I know. That's going to produce some parabola, probably something like that. Okay. Now, Caleb, since you're up here, I want you to in green, put it some random locus up there. Mark some random locus for me. Don't ruin my parabola.
I won't.
Good enough. Just make the point big. Okay. So that is some random locus. Do I know its coordinates? No, it's some random locus. So we're going to label it x, comma, y. I can do that, right?
Yeah.
Because that's an ordered pair. Don't count. Don't count.
Wait, what? Oh.
I shouldn't have used the grid like that. Because these are supposed to be general. Okay? They're not, they don't have any numerical values. They're just out there someplace. Because just x, y could have been any other point on that parabola. These are just generics. Okay? On the parabola. But this could easily be any one of them, right? It could be the one here. It could be the one here, here. So it's just some random one. Now, here's what I do know, though. This parabola, the distance from my focus to that point has to be the same as the distance down to my directrix, doesn't it?
Yeah.
Okay? So if I were to mark the point that lives right here, what are its coordinates?
Stop.
How much time?
Not you, Bob.
X negative y.
It would have a value of x, yx. It's on the same x value, isn't it? Do you see this line here? It's the same x. But what about my y value? Negative p.
Because y is way up.
Negative p because it's on the directrix, right? All right, cool.
Wait, what are you trying to?
This distance needs to be equal to this distance if this is truly a parabola.
So it's not.
Well, obviously it's not, but we're pretending it is because we're trying to prove this. So that means mathematically, good old Pythagorean theorem, that means that the distance between these two, so let's go and do that real quick. It would be the square root of, let's see, x sub 1 is x, right? Minus 0 squared plus y minus p squared. Everyone see that?
Yep.
Has to equal the other distance.
Wait, what's the other distance?
Well, the other distance, let's take a look at those. It's the square root of x minus x, quantity squared, plus y minus a negative p, quantity squared. Okay, and the blue is I'm just gonna draw it in blue, so you know what I'm talking about. The green line is the green part of the equation. The blue line is the blue part of the equation. If there are any questions at this point, please ask. Because at this point, it's just algebra.
Algebra?
Please make sure you understand everything that's been put up there. Yeah?
Why is the blue one, the x minus x, why is that different than the y minus?
Well, remember, I have to take x sub 1 minus x sub 2, correct?
Yeah.
Well, what is x here? Some distant x,
Yeah.
but that's the same distance x, isn't it?
Yeah.
Because it's on the x value.
Yeah.
So x minus x, quantity squared.
I'm more asking why is there one negative sign for the x and then but there's two minus signs for the p.
Because p is already negative here.
Okay.
See? If I did y minus something, but our coordinate has a negative p already.
Okay.
All right?
Thank you.
All right, we're good? May I continue?
Yep.
Anybody show thumbs up here? Everyone understand what we got up there? Still writing? All right, cool. It's not so bad, huh? I'll just wait for you. No. Go for it. We will wait for you.
Hey Munoz, have you solved all of those puzzles up there?
Someone's meditating. You got slapped by a bottle. We're good? All right, cool. Here we go. On the left side, x minus 0 is just x, right? So that's x squared plus the quantity y minus p squared. That equals, let's see here, x minus x, well that's 0. 0 squared is just 0, so that's gone. Correct? So I've got y, the quantity y, plus p squared here, don't I? Everyone cool? What's x minus x? Right? Okay, cool.
Oh, I missed. Dang it. Do you have white out?
That's why you don't do stuff in pen.
Steve, but all I own is pen.
Would you like to?
So all I did was clean up the inside of the radicals. May I continue?
Yeah.
All right, cool. I don't like these square roots, these radical symbols. So I'm going to square both sides. So if I square this side, I've got to square that side. Well, that's nice because that just gets rid of this. And I'm just left with what's inside. So I've got x squared plus the quantity y minus p squared equals the quantity y plus p squared. Right? Just what's inside. Time to expand. And it goes like this.
Wait.
I can wait.
I'm still writing.
Okay, may I continue? So x squared is just by itself. Here's how I'm expanding this part of it. That should read y squared minus 2yp plus p squared. That equals, and I'll do the next part in green.
Why is that 2y?
It's a perfect square. I'll get 2 of those. Over here I should get y squared plus 2yp plus p squared. So let me raise this up a little bit. You can see what I've got. Cool. Anybody see any commonalities on both sides of the equation?
Yeah.
What's common?
Y p plus p squared.
The p squares, so p square and this p square can be dropped.
The 2yp.
The y square and the y square can be dropped.
Wait, can you cancel out?
So let me clean this up. I've got x squared minus 2yp equals 2yp. Well, that's nice. If I move this 2yp to the other side, as in plus 2yp, I would get x squared equals 4yp or 4py. And there, my friends, is the equation of that parabola. You didn't see that coming?
No. Wait, is this just like proving the equation?
That's what we did.
I didn't realize it's like 2 plus 2 is
When you said proving the equation, I thought you were going to do like a column proof. I was like waiting for you to.
Oh, I think you're gonna bring up the video of the British student.
We could do it with the 2 column proof, but
Please don't. That guy's video was actually fun.
we just proved the equation of the parabola. You would do the other thing, but it's the same thing. You would be accepted. You would end up with y squared equals 4px. So the question was, does this proof also work for the other one? It's very similar, except your distances would match other coordinates, but it's the same idea. So it would, if you follow the same process, you would get the same equation as y squared equals 4px. Any questions on this? Wasn't so bad. Good. Well, that's the beauty. X and Y are any random point. So what I've done is I've proven that every point on this parabola is equidistant from the focus and the directrix.
So how would you prove that with a real parabola? Like just replace x and y with
I don't have to prove it with a real parabola. I just proved it for all parabolas. Is there anything that identifies this specific parabola? No, there's no defining characteristics. This is a generic parabola. This could be molded to any other parabola that exists. And how many parabolas are out there?
Many.
One.
One. One true parabola.
I wasn't.
Thanks, Matt Parker.
Wait,
I'll let you
so
know from that video.
Guy had a little shout out there.
for like homework.
What's up?
Sorry. Bye after this.
Yeah, I know.
Why would you like find the square root of it at the beginning?
Because remember the distance formula? Here, let's answer your question. We know that Pythagoras' theorem says a squared plus b squared equals c squared, correct? Now, so let me just show you that real quick. So if I had some point here and some point there, then I can kind of make this right triangle here, which would give me a, b, and c. So if I want to find this distance, well, that's technically c squared, isn't it? So if I wanted to find c by itself, I take the square root of both sides. Therefore, I've got c equals the square root of a squared plus b squared. Now, a squared is simply the distance between 2 points, correct? So if this is 0, and we'll call this 3, 0, then what's the distance between these two?
3.
And the way you actually do that is you go 3 minus 0 gives you 3 for distance. So that's why it was x sub 1 minus x sub 2, quantity squared, by the distance formula. And that's why you have those square roots. So if c was some other distance that I was talking about, then that distance should be equal to the other distance. And that's why they were both square roots. Okay?
So why do you have to put in the square root symbol if you're just going to cancel it out?
Because we have to start with something that we can't just jump into some point like that. We have to prove that this is going on, right? So what I did was I started off saying that I've got a distance compared to another distance.
Okay.
And that distance is this green distance compared to this blue distance. And obviously they're not the same, but because it's a proof,
Yeah.
that doesn't have to be exact. I'm just proving that those distances are the same. Okay?
Give me cough drops.
No, for the
Already asked.
umpteenth
You,
time.
no, you never gave me a specific answer for that.
Yes, he did.
No, he didn't. For the cough
All right,
drops.
I'm done.
Yes, he did.
Kara gave me an answer.
Stop.
But